Hey, Calculus. Today we're going to look at how to apply the chain rule when we raise a function to a power. You go ahead and present, and we'll get started. Okay. So once again, it's kind of a combination of both the chain rule and the power rule, like we've seen in class already. But I don't think it's too difficult. Let's take a look. So here's the rule here. So combine the chain rule with the power rule. If we have a function raised to a power, we're going to apply the power rule here. So we're going to bring that exponent of n down as a coefficient and then take one power away, but there's just one little extra step. We also have to multiply that expression by the derivative of whatever is inside the parentheses here. Okay, so whatever that g of x function is, we have to multiply that by the derivative of it. So let's take a look at three examples that'll help us understand this a little bit better. First one I want to take a look at is this one right here. So if we have a function h of x equals 3x plus 2 squared, find the derivative of h. Okay, and I'll leave the rule that we have down here in the corner. So here's what we do. We say, okay, g of x is 3x plus 2. Therefore, the derivative of that is just 3. Okay, so we've got that taken care of. Now, I know that we're raising it to the second power, so that means that the power that I'm going to have left over is just going to be 1, so I don't really need an exponent anymore. So bringing that all together, we get h of x is equal to 2 times 3x plus 2 times 3. Multiplying all those together, we get h of x is equal to 18x plus 12. Not too bad. Okay, let's take a look at another example. Let's say we have this. Let's say h of x is equal to 1 over x plus 1 squared. We want to find the derivative of h. Okay, so this sort of rational function where we have a function in the denominator. We obviously don't want to pull out the quotient rule. That's doing a lot of work for just one little function here. So we want to rewrite this where we don't have to apply the quotient rule. In this case, we can write it as h of x is equal to x plus 1 to the negative second power. Okay, so take that negative power, that's what that means, and we rewrite it so that way we have our interior function and the derivative. So the interior function is just x plus 1. The derivative of that is just 1, and we take a look at our exponents. So now our exponent for the original function is negative 2. We take 1 away from that, we get negative 3. Here's how we bring all of this together. Therefore, the derivative is going to be negative 2 times x plus 1 to the negative third times 1. Thankfully, negative 2 times 1 just becomes negative 2. And we can rewrite it where we have x plus 1 now in the denominator. So it would be negative 2 divided by x plus 1 to the third power. Another way we could look at this is, what if we have the square root of a function? So let's say we have this problem here. Let's say y is equal to the square root of x squared plus 16, and we want to find the derivative of that example. Once again, we want to rewrite it where we have a rational power. Okay, so we can write this as y equals x plus 2 plus 16 to the 1/2 power. So this makes it a little bit easier to work with. Here's what this looks like. So that means our interior function is x squared plus 16. The derivative of that using the power rule is just 2x. And then we once again want to contend with our powers. So if our original power is 1/2, that means that taking 1 away from that 1/2 would be negative 1/2. So we bring all this together and we get 1/2 times x squared plus 16 to the negative 1/2 power times 2x. Now we want to simplify this because that's a lot going on. Of course, this is a correct identification of this, but if we were to simplify it, our 2's in the denominator of 1/2 and the coefficient of 2 right here would cancel out, and we're left with just x divided by the square root of x squared plus 16. Make sure you come to class tomorrow with your homework done. It's page 297 in the OpenStax textbook, numbers 228 to 232. We're going to look at these rules a little bit more in depth. Hope you guys have a great day.